Hi, this is question 20 for the ACT math exam we're working through, and this one is going to test your ability in looking at similar triangles and also some, some basic geometry. So here we go. What we're going to do here is just read the question quick, and then we'll solve it. So the lengths of three sides of a triangle are in the ratio of 3 to 4 to 6. The perimeter of the triangle is 143 centimeters. What is the length of the longest side of the triangle? All right. So we have this triangle here that has a perimeter of 143. So we know that. So 143 equals the perimeter, right? So, and then we know that the sides of the triangle are in a ratio to one another, right? Well, one way to solve this is to think about a smaller triangle that's similar to this triangle. And what I mean by similar is that it has the same angles, but it has different length sides, right? A similar triangle has the same angle measurements as another triangle, but it does not have the same length sides. So let's pretend we have this. Well, what I'm going to do is I'm going to say, all right, well, if this large triangle has a ratio of 3 to 4 to 6, I can imagine a smaller triangle that has sides of 3, 4, and 6, right? And then I can set up essentially a ratio of my own, or a pair of equal fractions that allow me to determine what this side, the longest side, of my large triangle is. Because I know that the longest side of my smaller triangle is 6, right? And I also know the perimeter of my smaller triangle because I'll just add up the sides. 6 plus 4 is 10, plus 3 is 13. So I know I've got 6/13, so part over whole. And I know that that's because I've got similar triangles, because I know that this triangle is in the same has the same ratio of sides as this larger triangle. By the way, that's another definition of similar triangles, that the sides are in ratio to one another. So any two triangles with the same angle measures are always in ratio to one another in some combination of numbers. So anyway, I've got this, my longest side is 6, my perimeter is 13 of the smaller triangle, and I don't know the measure of the longest side. That's what I'm trying to solve for my in the problem here. So I don't know the longest side of my larger triangle, but I do know the perimeter because it's given in the problem. That's 143. All right, and now I've got two equal fractions. Well, with two equal fractions, with one numerator having an x, I know that I can cross multiply to solve for x. So let me go ahead and do that. So I've got 13 times x. Well, that's 13x, x. And I know that that equals 6 times 143. So let me do that on the calculator. 6 times 143. And that, whoops, I didn't do that right. 6 times 143. And that equals 858. So 858. All right, now I just do a little bit of algebra. I divide each side by 13 to get x by itself. So we would get x, 13x divided by 13 is x. So x equals 858 divided by 13 equals 66. All right, so that's 66. So x was originally, that's our longest side here, and since the question is what is the length of the longest side of the triangle, we actually solve for it. So x equals 66, and that is our answer, D.